I'm going to do another example question here on Coulomb's law. This is example number 2 from the handout that you got last week. It says the two spheres in the previous example, example number 1 that we did last week with these two charges, positive 5.55 and negative 2.00, these two spheres are touched together. And then they're separated by their original separation distance of 5 centimeters. What's the electric force that acts between the two charges? Isn't it the same as it was before? Why isn't it? Okay, good. If they're identical charges, identical objects and conductors, then when we touch them together, the charges should balance. So instead of being 5.5 and negative 2.0, now my charges will be, well, whatever the average of those two charges is. We add them up and we divide by 2. Let's do that now. Let's say I had 5.5 times 10 to the minus 7 and negative 2 times 10 to the minus 7. Divide it by 2. So the charges become 1.75 times 10 to the negative 7 coulombs. That's both charges now, right? Now the force before I touched them was whatever it was in question number 1. But now after I touched them, since the charges are different, the force is now different as well. So I get 8.99 times 10 to the 9 times my new charge. By the way, this morning when I wrote this down, I said 8.99 times 10 to the 9 times 1.75 times 10 to the negative 7 squared. Would that work? That's the same thing, right? Divide up by r. Make sure you put it in meters. We do that, we calculate that force, and we end up getting 0.110 newtons, or you could say 1.10 times 10 to the negative 1 newtons, whatever works for you there. Make sense? Really just two questions in one, right? Touch them together, what does the charge become? All right, there's question number 1. Question number 2 is, what does the force become after the charges have been changed to their new values, the 1.75 value? I'd like you to take a look now for the next few minutes at worksheet number 6. This time, let's take a look at questions 7 and 8, please.